Okay, so this is going to be a video doing a molecular orbital diagram for a slightly more difficult atom. Let's look at something like carbon. So the electron configuration of carbon is 1s2, 2s2, 2p2. So we draw our energy diagram. Here's the 1s, 2s up here, and 2p right here. And our second atom, 1s, 2s, and 2p right here. I'm going to redraw that other 2p. Let me erase. Okay, so that's our situation, and we have 2 electrons here, 2 here, and 2 up in the p, like that. And for our other carbon, 2 in the 1s, 2 in the 2s, and 2 in the 2p. Okay, so we already know how the 1s orbitals overlap. We get this. And we fill in with electrons. This is our sigma, sigma star. And the 2s are going to do something similar. We have an orbital like that, like this. Put our 2 orbitals in, and these are sigma because they're from s orbitals. And s orbitals are on the bond axes, and this one is a sigma star. I'm running out of room. And the p's are going to overlap like this. Now, typically we expect this orbital here to be lower than these 2, and there's reasons that I'm not going into here. It's beyond the scope of this book. We just memorize that it's in this position. And so I put in my electrons, and I get 1, 2, 3, 4. These 2 orbitals here are my pi orbitals. They're from overlap, if you remember, of orbitals that are overlapping like this. This is a sigma orbital. I didn't have a lot of room here to draw, so I'll color this one sigma orbital. Okay, and that's from the p orbital, so it looks like this. Oop, I wanted that to be blue. Got to be a different color. Okay, and that's a sigma orbital, so I'll label it sigma. I don't have room to draw it in there. Come on, what's wrong with my pen? Here we have 2 pi anti-bonding, and we have a sigma anti-bonding, sigma star. They have these 3 top orbitals, the sigma, the pi, and the sigma star have no electrons in them. All right, so I'll introduce bond order here. Bond order is equal to the number of bonding electrons minus anti-bonding electrons divided by 2. Bonding electrons minus anti-bonding divided by 2. So for this one, I have, that's a bonding orbital, 2, that's a bonding orbital, 2, 4, 5, 6, 7, 8 bonding electrons minus anti-bonding orbitals. Let's make those circle them green. Sorry, my battery ran out. So here we go. 8 bonding electrons right here minus the anti-bonding, and I have 2, 4 anti-bonding divided by 2, and that equal 2. So that's the bond order of C2. Okay, that's enough for here. I'll do the other example. So boron, carbon, and nitrogen follow this pattern. oxygen, fluorine, and